So unfortunately, due to the fact that there is a midterm in the room that we're going to lecture on, we switched spots and I could not record the lecture, so I'm just going to record this sort of after the lecture. So this isn't live, this is just me recording after the lecture. But anyways, week 4, we're going to be learning about the command line interface. So we're sort of preparing for the back end. So this week we're going to learn about the command line, and then the week after, next week, after reading week, we're going to be learning about Git and GitHub. So after those two, we're going to be diving straight into the back end. So this week we're going to be familiarizing ourselves with the command line. And yeah, so let's get started. So what is the command line? The command line is basically a way of interacting with the operating system without using graphics. So your typical way of interacting with the operating system is with GUIs. So you sort of use your mouse and click around and drag around. But the CLI, or the command line interface, allows you to interact with the operating system with just text. And because a lot of development tools are sort of built on CLI, because CLI is sort of like the OG way of interacting with the operating system or with the computer. It used to be the only way, right? So a lot of development tools don't have GUIs on top of them, right? Git, Node, just to name a few. So because these applications do not have GUI on top of them, we have to learn the command line interface to sort of interact with these software. There are third-party softwares that interact with Git and maybe even Node, but it's sort of like a third-party thing that sort of is built on top of the existing software. So it's best to sort of learn the command line and how to use these softwares. So there is a bit of a difference between the terminal and the shell. They're used mostly interchangeably, but if you want to be very strict about it, terminal is the app that actually runs the shell. So terminal is the app or the window that actually runs the shell, and the shell is actually responsible for executing the commands, and the shell is what determines the syntax of the commands as well. So for Bash, this is probably the most popular shell, born again shell, and it is the default shell for most Linux distributions, I believe. And it has a very similar syntax to Z shell, which I'm going to go over in a bit. But Bash is like the first extremely popular shell that a lot of people use, and I highly recommend using it. But more common now is Z shell, and Z shell has been more popular now than Bash just because of its plugin ecosystem. It's such a vibrant plugin ecosystem that allows you to really extend the functionalities of your shell. So if you want to sort of get into using your command line now, I would highly recommend you use Z shell and not Bash, although the differences are not big if you don't count the plugins. So another shell is a PowerShell, which is built on top of the .NET framework. It's Microsoft. It's the default shell on Windows, and if you want to use it, that's totally fine too. But we're not going to learn about that here. Right here, we're going to learn about Bash or Z shell, just because most development things are sort of on top of Linux type stuff. So, but if you want to use PowerShell, that's totally fine too. There is definitely there are definitely a lot of people who use it as well. So there are slight differences between Mac users and Windows users. For Mac users, iTerm 2 is an application that you can install that is sort of better than the default terminal app. So iTerm 2 allows you to have like split panes and tabs and even image and videos apparently. So it's just a better way of using the terminal. But you don't have to use it if you don't want to, but it's just something that a lot of developers use. And then for Windows users, we have default, which is command.exe, which is pretty garbage in my opinion. A better application or con host is perhaps the one that's default. Command.exe is more like the command prompt. But Windows Terminal is actually better than the default thing, whatever you're using, whether that's PowerShell or Windows Console Host, because Windows Terminal allows you to have multiple tabs, and each of these tabs can run multiple shells, right? And here's sort of where you can see the difference between a terminal and a shell, because this is sort of a shell running inside a terminal and another shell running inside the same terminal, right? The terminal application. So yeah, Windows Terminal would highly recommend using this rather than using the default one, because it has more features. It's more modern. It's a better way of doing it. And if you want to know more about how to install these type of things, just Google it. And if you want some guidance in our repo, we have installation instructions for week 4 and the as a markdown file in the root directory. So here we specify how to install the software. So, and by the way, with all other weeks, if we have installation instructions, for example, with Node and Git, they will all be posted on as a markdown file in the root directory as well. So you can look into that maybe before you come to the tutorial if you want everything set up and you want to follow along. So how do we run Bash and Zish on Windows, right? I mean, so far we can only run PowerShell on Windows. So to run Bash and Zish on Windows, essentially running Linux on Windows, one way is to use Git Bash, and Git Bash is a way of installing Git, so it comes with Git, but it also comes with Bash. And so if you install Git Bash, you'll have a window. You have an application that you can launch that will essentially allow you to run basic Bash commands as well as Git. Another way, and this is sort of a better way of using Linux, is to use WSL2, Windows Subsystem for Linux. And this is it's very hard to explain, but it's essentially, here's the description. It works by running a real Linux kernel inside a lightweight VM on Windows. So it basically runs a tiny little Linux on your machine without having to partition your hard drive. So this allows you to run basically anything that Linux can run, right? Any Linux binary can run on WSL2. So that includes Bash and Z Shell. So and the installation instruction is on the README, and if you can look it up how to install it if you want as well. It's not too difficult. So anyways, so I'm gonna come back to this, but so we learned about these. Okay, so now I'm gonna actually demo a few very useful commands that you have to know about. So I'm going to open up the terminal, and in this terminal I'm going to zoom in here, and then I'm going to type in some commands. So here's the terminal, and then this is the current directory that I'm in. Tilde stands for the current user directory. If I type in pwd, it stands for print working directory. You can see that I'm currently at /users/Gavin. So that's my user directory. If you have multiple users, you have /users/ something else, right? Okay, so right now I'm in the user root directory. The two most common commands that you will use is cd and ls. So ls stands for list, I think, and what it does is just lists all the contents in your directory. So that's folders, files, whatever it may be. So you can see here that I have a bunch of folders and files on my root directory. Another really useful command is cd. So it stands for change directory, and what I can do is change to a different directory, right? Move into a different directory. For now, you'll see that terminal is very similar to a file explorer right now. So if I want to go into desktop, for example, I just do cd desktop, right? And I'm auto-completing it with tab, so desk, and then I can press tab and it'll auto-complete. So cd desktop, and I'm going here in the desktop folder that have an ls, and now I have the QWeb tutorials folder. I can cd into that as well, right? And I ls, and I see the files inside the QWeb tutorials folder. So here's how you sort of move around the file structure. And so if you want to move up a directory, dot dot represents the directory above. So if I want to move up a directory, I go cd dot dot, and I move up a directory. So now I'm back on desktop, I do another one, and I'm back on the user root directory. Dot represents this current directory. So if I type in ls dot, you can see here that it's just basically the same as ls, but if I do ls desktop, it will sort of list out everything that's inside desktop. So dot stands for this directory, dot dot stands for the previous directory, and if you want to go more previous, you just go dot dot slash dot dot. All right. So anyways, tab completion. Okay, so the basic syntax, as you may have already seen, is you type in the command, and there will be perhaps some options that you can type in. Okay, I'm going to clear the terminal with clear. Another way of clearing the terminal is Control L, by the way. So I can do ls-l, and -l, dash is to specify an option, and L is the option of long. If I type in this, you'll see here that I have sort of long form of the list. So I can see the permissions, I can see the owner, I can see the file ID, I can see the date modified. So a lot of commands have sort of these options. We first type the command, and then you type in dash and then some option, and then you type in the argument. So for example, if I cd into desktop, desktop is the argument, right? So the basic syntax is your command, and then some option, right? And then the argument. And the argument there can be multiple arguments, and they'll be separated inside. They'll be separated by spaces. So that's the basic syntax. And so another useful command is cat. So if I go in the desktop folder, I go in the QWeb folder, I go in, I'm going to remove the text file.txt. And let's say I want to cat out the README, right? So there's a README. If I want to cat out the README, what cat does, cat stands for concatenate, and it concatenates all the argument, all the files that you have put as arguments into one blob of text. So if I just type in one file, it will just cat out or just read out that one file. So it's basically a way of reading the file. So cat readme, as you can see that here's all the files, all the text in that file. And if I, for example, want to do, I go in the website folder, I can cat out index.html as well as a script.js. And what it'll do is it will print out both index.html as well as the script. So that's how you go about it. I'm gonna remove the script.sh. Okay, so to create a file, I can use touch. So to demo this, I'm gonna open up this folder in VS Code, and to do that, I can type in code dot, and then inside here, I can actually go in and see the files here in VS Code. But anyway, so if I type in touch sample.txt, just as an example, you can see here that a new file has been created. If I want to create multiple files, I just do one.txt and then another file separated by space, right? So this is 2 arguments, and it'll create both of those files. To remove files, we type in rm. So rm1.txt, 2.txt, and maybe the sample as well, and that will remove it. So to make folders, we used mkdir or makedir. Make directory stands for make directory, and then the name of the folder. So for example, public, right? Doesn't really matter. So it will make a directory called public, and so let's say I create another file. To move a file inside another folder, I can do mv, right? So mv.txt and then public. So move the file.txt inside the public folder. And you see here that the file.txt is now under public. So, you can just sort of play around with it. To remove a folder, it's a bit more complicated. You can't just remove public because public is a directory and there are stuff inside of it. So to remove a directory, you have to do rm-rf public. So what that'll do is this option stands for dash recursive and force. So recursive will delete everything inside that folder, and then force will force delete it without asking for confirmation. You have to be very careful with this command because when you rmrf a public, or when you rmrf a folder, you will never ever be able to retrieve it ever again. So just be careful with it. But I know for a fact that public has nothing on it, so I can feel pretty safe about this. So that's how you remove folders. And then man is a command that allows me to sort of read the manual of the of different commands. So man stands for manual. So for example, if I don't know what ls does, I can do man and then ls, and then it will show me sort of how to use ls as well listing all the options that I have available on ls. So for example, like with dash capital L, it follows all symbolic link and all that type of stuff. So if you forget how to use a command, a very quick way of just reading up about how a command works is with the man command. So code, I just showed you that with code you can actually open up VS Code. So if you type in code dot, this opens up the VS Code on the current directory, right? Dot stands for current directory. If I do code script.js, this opens up the script.js file in VS Code, right? So I believe this is something you have to set up if you've never done this before, but it's not too difficult. You can Google it if you want. But this is a very useful command that I use a lot. So we also have expansions. So as I've already said in the beginning, tilde stands for the user root directory, and this basically expands to slash users slash Gavin, right? So this expands to that, so they're called expansions. And star star basically stands for everything. It matches everything. So for example, if I cd up a directory and then I type in cat website star, right? What this means is I want to cat out everything in the website folder slash everything, right? So website slash everything. cat out website slash everything, and it will cat out basically every single file in that folder. So I have the CSS, I have the JS, I have the HTML, right? Everything that's inside. So star stands for everything. So okay, so now we move on to I/O. So with I/O, you have standard input, standard output, and standard error. Standard input is basically it's sort of an invisible stream of data fed into a command. Standard output is a way of well, you see the standard output. The output of the command is that you see is standard output. And then we have standard error, which is the output that you see whenever there's an error. So for example, if I go in here and I type in a ls dash a nonsensical option, wow, that worked. What does this even mean? Anyways, let's say I ls something that doesn't exist, right? Then it will say ls this is no such file or directory. So this means that this is an error, right? That didn't go right. So this is printed as a standard error. But if we type in ls here with properly, this is actually standard output. You don't see much of a difference, but they're actually in different data streams that you can capture differently. So standard input is sort of like something different. It's not the argument. So for example, if I do ls website, this is not standard input. This is just an argument. Standard input is sort of an invisible stream of input. And the best way to see it is with piping. So for example, if I want to, so grep is a command that essentially searches for text. So if I type in grep and then week, what this does is grep takes in the text from standard input and then searches the argument. So it will take in text from the standard input and then searches weak in that standard input. It's basically Control F or Command F. And here you sort of the program sort of pauses because it's waiting for me to type something in it. But a better way of using it is just piping a output of a command to this grep. So I can do cat readme, right? This will read out the readme. So if I do cat readme and then I pipe that output, the standard output into the standard input of grep, and then I search, for example, weak, what it'll do is it will find all the lines that actually have the word weak in it, right? So grep takes in that standard input. So that's how we interact with standard input. Another way of handling output is with redirection. So for example, if I type in ls, I go into website, we have a lot of these files, right? Let's say I want to concatenate index.html, script.js, style.css, right? And then now you sort of see like all this, right? All the file concatenated. Let's say I want to do that. And by the way, I'm using a previous command with the up arrow or control P as in control previous. So I cat out all these files and then I can actually redirect the output to a specific file. So I'm going to name this file just like maybe output.txt, right? Doesn't really matter. So after I type out this, if I go to that folder, you'll see here that output.txt has actually all the text concatenated, HTML, CSS, and JS, right? So this, you can imagine, is very useful whenever you want sort of the output to be placed on a folder or write the output to a file, rather. So very useful stuff. Yeah, it allows you to basically redirect the output to a file. So that's basically how you do piping redirection. I showed you echo, I showed you grep, or maybe I didn't show you echo. Echo is a way of printing, so it's basically print. If I do echo hello world, it prints hello world. So okay, now we have shell variables and environment variables. So with shell variables, you can actually create variables. So you can actually create variables in this shell session. If I do, for example, str equals to string, right? So now the str variable is equal to string. I can actually echo out this variable with the $sign. If I prepend something with a $sign, I'm saying that this is a variable, and it prints out string. Without the $sign, I would literally just print out str. So that's very, very useful. And when we learn backend, you'll see how this is useful in a bit. But this is sort of how we declare session variables. And then with environment variables, it's basically the same thing, except the environment variables are sort of built into the environment. They're sort of global variables that already exist. So for example, I can echo out shell is one of the global environment variables. And you'll see here that the shell variable is the string /bin/z shell, which is the actual shell binary that I'm currently running on. So very useful stuff. And then we have shell scripting. So Bash is actually a programming language. You can actually pre-write these scripts of Bash scripts or Z shell scripts and actually run them on a command line. So just to show you, I can write script.sh. .sh is the sort of extension for shell scripts. And the first thing we need to do is a shebang, hashtag, and then a bang, and then point to the directory of the shell that will actually be running this shell, the script, so, which is /binary/bash. And bash is a binary, and then I can write my script. So hello, echo hello world, right? And then if I save that and I go back here to run the script, I just point to it. So ls, right? So I can say .script.sh. And this won't work because I don't have permission. I don't have execute permission. To change that, I do change mod plus x, right? Plus x stands for add execute permission to the script.sh. And now I can run script.sh. And now you can see here that it echoes hello world, right? And you can sort of imagine what this sort of looks like on scale. When you create more and more bash scripts, you can actually automate a lot of stuff with simple scripts. So so we can run scripts, but we could also source scripts. So you can actually create variables inside these scripts, right? So we can say message equals to hello world, right? So that's a variable. But if you see here that I actually, if I, for example, run this script, I won't have access to a message, right? And the reason for that is because when you run a script, it sort of runs the script in a sub shell and then just pipes the output out to the current shell. So it doesn't actually run the script in your current shell. So you don't actually maintain or retain that variable. To actually run scripts on your current shell environment, you have to source it. So source will basically do the same thing. It will run the script, but on this current shell session rather than a sub shell. So when you source, then you have access to the message variable. So this is something that you'll use a fair bit. So so that's sourcing. Alias, so for example, if you have certain commands that you want to use a lot, for example, ls-l, maybe this is something you use a lot, or ls-a, that sort of lists out everything, including the dot files. Doesn't matter what it is. If it's a command that you use a lot, you can use alias. So you type in alias and then ls. For example, maybe I want the L. Whenever I type L, I want it to be ls-l. So alias L equals to the string ls-l. And that's how I set the alias. And now if I type L, it would then show the long form, right? So a lot of long commands that you don't want to type out, you can alias them. And if you want to see all the alias that you already have, you can type in alias and you'll see here all the alias that you have. So that's aliases. But one problem that we have is that, for example, I have the aliases. Maybe I set up the perfect shell environment with all the right variables and all the right fancy stuff. But then the moment I quit my terminal, right, and I open it back up, it's all gone. So I type in ls, I type in L, alias is gone, right? No longer there. So this is a problem because maybe we want certain things to run automatically when we start a shell session. And that's sort of where .zishrc comes in. .zishrc is a way of basically whenever you run zish or zshell, it will source the .zishrc file automatically. So, and your .zishrc file should be in your user root directory, so tilde. So I'm already in here, so I'm gonna actually create it. So touch.zishrc. And then I can actually open this up in VS Code. And in VS Code, I can type in the things that I want to run on this whenever I start Z shell. So for example, if I type hello world, right, then whenever I run Z shell, it will print hello world, right? So if I quit the terminal, I open it back up again, you'll see here that it prints hello world. So in here, you can actually put the aliases. So you can put alias L equals to ls-l. You save that, you go back, you quit. And then whenever you start your terminal session, which will start the Z shell, Z shell will source this file and you'll have access to the alias. So that's how you set aliases. on a more permanent basis, or on a more permanent in a more permanent way. .z profile is the same thing, except .z profile is sourced before .zshrc. So .z profile is sort of for environment variables, and .zshrc is more for like changing the behavior or appearance of your terminal. But for the most part, you don't have to use .zsh profile if you don't want to. So that's how .zshrc works. And then I'm going to go over a little bit about package managers on a Mac OS. The most popular package manager is Homebrew. This is sort of the thing that most people use to install stuff, including Git, but a lot of plugins for Z Shell as well, and installing Node, just everything really. So you just, to install Homebrew, you copy this command, run it in your terminal, and you'll have it. So I already installed it, so I'm not going to run it, but if I do brew list, it sort of lists all the software that I've installed. As you can see here, that I install basically every software that I use on Homebrew. So you can basically replace App Store or going online and search up the app that you want with Homebrew. So right, I install the browser, I install Zoom, I install VS Code, I install most of my apps, even if they're GUI or not GUI, right, like Node or any command line interface stuff with Homebrew. So and it doesn't have to be Homebrew, but using a package manager will be very, very helpful. So if you're on a Windows and you're using WSL2, the default package manager will be apt. apt is the same thing. You can do apt install and then whatever software you want to install. So if I want to install, for example, Firefox, I brew install fire-fox or Firefox or whatever. And if you don't know the package name, just search it up, right? Firefox, Homebrew, and then it's just Firefox. Yeah, so I can just brew install Firefox. I'm not going to do that, but you can see how much easier this is than just going on the Firefox website. So, package managers, extremely useful. I highly recommend you use them. And so now we're going to move on to plugins. So right now the shell looks pretty bland and quite frankly not very user-friendly, which is for the most part fine if you're used to using the command line, but for new users this may be a little intimidating. So there are plugins that actually, as I've said in the beginning, that extend Z Shell very, very well. So Z Shell has this amazing plugin ecosystem that you can tap into. The three most popular plugins that people use is syntax highlighting, P10K, power level 10K, and auto suggestion. So syntax highlighting, if you just Google Zish syntax highlighting, and you look at the first result, you see the repo for Zish syntax highlighting. And essentially how these plugins work is they basically have a .zish file, and all you have to do is source them. So you can literally just, copy these two files and then just source them in your .zshrc and you're done. There's no magic here. So what syntax highlighting does is it just sort of like whenever you run a correct command, it has like green. If it's a wrong command, it's red. You can sort of see like variables are highlighted as well. So it's very useful. So you can go and install the MD on how to install. But I can tell you right now, the process is pretty simple. For example, if you're using Homebrew, I can use Homebrew to install this. So if I use Homebrew, I just do brew install Zish syntax highlighting, right? So go back and brew install Zish syntax. I already have it installed, so I'm gonna do reinstall, but you should do install if you haven't installed it. So it's gonna install all the stuff, and then now in here you'll see that to activate the syntax highlighting, add the following to the end of your .zshrc, which is just simply to source the script. So Homebrew basically downloaded the repo in this directory, and all you have to do is source it. So I'm gonna do it. So I'm gonna copy this. I'm gonna go to zshrc. I'm gonna source that, save that, quit, launch it again. Now I have syntax highlighting. So when I type something that doesn't make sense, it's red, but if I type an actual command, it's green, right? So it's a very useful way of knowing whether a command exists or not. So another plugin is auto suggestions. So Zish auto suggestions. And same thing, auto suggestions basically allows you to, it suggests basically previously ran commands or commonly ran commands. So same thing, if I use Homebrew, I'll just search Homebrew, right? Brew install Zish auto suggestions. So brew install Zish auto suggestions. And same thing, to activate this, you just source the script. So I'm going to do that. I'm going to source, go here, source it, quit, launch it again. And then now I have auto suggestion. So for example, if I do echo, previously I did echo hello world, and it already suggested hello world, right? But if I do hi, and then I echo, and you'll see here that I suggested, I just have to type in the arrow key, and then it autofills, right? So it's very useful for very commonly used commands. So saves a lot of time. Another really useful and really fancy plugin is called P10K. It stands for Power Level 10K. And what P10K does is it modifies your prompt. Instead of the boring prompt that you see in the terminal, it sort of modifies the prompt so that it shows more stuff like the get sort of status, the time it took for the process to run, or the current time, or it's just a very sort of customizable plugin that allows you to modify your prompt. So to install, the process is pretty much the same. If I go into the installation page and then I go into Homebrew, I have the brew install power level 10K, right? So I can do brew install power level 10K, and then installs power level 10K, and then we have the source. So we're gonna source that script here, save that, quit, launch it again, and because it's the first time launching, it will ask you to configure your prompt. So right now I don't have like the right font for this. To install the right font, you want to go to install some nerd font. So you go to nerd fonts and just install at least one of these nerd fonts. Basically a nerd font allows you to have symbols. Nerd fonts have symbols, and these prompt uses a lot of symbol. So I can actually go into the settings of the terminal app, whatever app you're using, and then change the font that I'm currently using. But I'm not going to do that here. So I'm going to say, no, this does not look like a diamond. No, yes. It's okay. So now it knows I don't have the special font. So it asks me, do I want, lean classic rainbow? I'm going to press 3 for rainbow, 1 for Unicode, N for no, 1 for flat, right? You can sort of customize this the way you want it. So sparse, concise, yes, sure. And then I will, yeah, okay. And then I will create a .p10k.zish file in your root directory. I already have one, so I'll override it, which is fine. And apply changes to .zishrc, yes. And that's it. And you see here that it has a much better prompt. If I go into my desktop, you see here that you have the directory up top, and if I go into the QWeb tutorials, because it's a good Git repository, it has this sort of Git status, right? So very useful stuff. And if you're running processes, it will sort of show you how long it runs on the right side. So very useful stuff. Right now, our terminal looks way better. But if you want to make it look even better, you can do p10k configure. You can reconfigure it, and obviously install the nerd font so you have the symbols and whatnot. So that's basically how plugins work. It's not that complicated, and I highly recommend you do use at least these 3 plugins. They will make your life much easier when you're working on the terminal and make terminal work just that much more enjoyable. Yeah, I can show you. For me, I have all my dot files, including the .zishrc, saved or backed up. So if I go back to the root directory and I remove the .zishrc, I remove the .p10k, and I go into the dot files that I already have, and then I get reset hard. Okay, so now I have the dot files, and now I'm gonna just basically link the dot files to the root directory. And then, yeah, and then if I open up iTerm, which has the actual fonts, this is my terminal, right? So I can type in ls, and you see here that there's like fancy symbols. I can go back a directory. I can go to, it also tracks recent directories. So if I go to like a recent project that I've been doing, like the Education 25 repo, I can just automatically fill that in, right? And tons of customizations you can do. I installed LazyGit. You can sort of track or use Git in a more GUI like interface on the command line. So lots and lots and lots of things you can configure. If you want to sort of look into how I do it, this is the repo that I have um, that I use to sort of configure my terminal. So, but you can definitely do it yourself. It's just a lot of Googling and a lot of just time. So, but you don't have to like rice your configuration. Just use something simple. Use these three plugins. They're absolutely crucial. In fact, I only have these three plugins plus one other plugin that I use, and that's really it. So, would highly recommend you use these plugins, taking advantage of them. And so, yeah, that's basically it. Hopefully, you guys can get more used to the command line, and then so next week or next week when we do Git and GitHub, you are comfortable with using the command line. So, yes, thank you so much.